All right, so what's an inverse? I want to show you what an inverse function is real quick.
Let's learn together.
Yeah, let's go. All right, so these 2 points right here are inverses. 2, 4, and 4, 2. All right, give me another example.
3, 6, and 6, 3.
Okay, 3, 6, and 6, 3. They're inverses. Now, take a look at this. What I just drew up there is the line y equals x. And so what happens is, if you want to find the inverse of something, you reflect it over that line. And what that's saying is, all the y coordinates become, and all the x coordinates become y coordinates, right? They just switch. So when you want to try to find the inverse of a graph, you just reflect it over that line. So one example is x squared. Then I have to do 2 of these, but that's an example of an inverse. Square root and x squared. And now you don't have to do all that crazy stuff, right? We're just going to talk about individual points. But that's what an inverse is, right? So xy becomes yx, and you just switch them. Okay, so what is the value of the inverse of 0, though? So when it's worded this way, what is the inverse of f at 0? Okay, now if you remember way back when we did evaluating functions, if it said f of 0, it meant go to 0 and then find the y coordinate. That's what it meant, which this answer would be 3. But that's not what it's saying here. It's saying find the inverse. So instead of the x coordinate, what is this? The y coordinate. So 0 is the y coordinate. So go to the y coordinate 0. That means here, anywhere along here. Where's the graph? It's at 6. That's what you're trying to figure out. So the inverse of f doesn't mean negative 1 power or anything like that. It just means inverse. You're looking for the x coordinate. Instead of the first assignments we did way back a couple weeks ago, where you were looking for the y coordinate. All right. Now, what if they give you a graph like this? You're going to have to manipulate this, move it around until the points are the inverses. All right. So here's what I'm talking about. Take a look at this point here. This first one. It's at -1, -2. And like I just drew on there a second ago, what do you do to find the inverse? Switch them. You don't change their signs or anything like that. You just switch their places. So -2, -1. So that's -2, but now I've got to change it to the y coordinate, -1. Now I do the same thing with this point on the left. So that's at -7, -5. Now I got to switch them. All right. So now I got to graph this point here. Those coordinates, -5, -7. And you should notice that kind of symmetry where there's a reflection right there. So let me show you this real quick. I did that and I drew a very careful line through here. Right? Pretty close. But it's a reflection over that line. All right. There's a couple other kinds of questions in this section, and I copied them over here. This gets confusing. It's kind of different notation. All right. Follow along with me. All right. What happens here? Because this is really funky. If you ever see something like this, normally we would use the numbers in the table, but do you see a 93? No. So that's a clue, first of all. Here's the idea. What happens if you do the inverse? Sorry, let's say you do something to 93. That's what a function is. So we do something to it, right? And then we do the inverse of it to whatever we did. It'd be like saying take 93, add 8, and then subtract 8 as an example. What do you have? You have 93. If you do the inverse of something and the original thing to a number, you end up right back where you started. All right, it's just 93. So another example, that would be like this. What if I had inverse of f of 17.2? What's the answer? Freaking 17.2. Okay, they cancel each other out, these two things. All right. What's it mean down here, though? This gets funky. So notice the difference between this and normal f of negative 15. This would mean I go to the x-coordinate negative 15 on the table and spit out the y-coordinate, right? Remember, these are x's, these are y's. But now it means something different. Right, so now I got to look, where's the y-coordinate negative 15? Well, there it is. What's the x-coordinate that corresponds to that? Negative 6. You just use the table backwards that we normally did. It's an inverse. All right, what if we're doing this down here on the left? We got to start with 7. Notice how it doesn't say inverse, right? Doesn't say inverse this time. So they're going to switch back and forth on you. 7 spits out negative 6. That means all of that on the inside becomes negative 6. Now do the same thing again, but with negative 6. What's that spit out? Negative 15. Okay, that's actually called a composite function. I'm a little confused as to why that's in there. I think they're just trying to get you to switch back and forth between inverse and not. All right, last one down here says start with the inverse of f at 4. Remember, inverse means start at the y-coordinate. That would be negative 11. And what's f of 9? Notice no inverse, right? This means start with the x. That's 11. So it's negative 11 plus 11. 0. All right, that's the first assignment. Second assignment says find the inverse of a function. This gets a little bit funky. Please pay attention here. Let's do 2 of them. These 2 right here. What you have to do is solve it backwards. So here's what I want you to do to start these. I want you to write it like this. X equals negative 2/3. Remember, we're finding the inverse. So what happens with x and y? They switch, right? And this actually means y. But what we're going to do is we're going to switch it. So first thing, switch x and y. Call this thing over here x and plug the y into the equation. Wouldn't hurt to write maybe this one down, is all I'm saying. Okay, then solve. Solve it backwards. Now, some of you might be able to do this in your head. Keep things straight. I want to solve for y. If I want to get y by itself, I'd do 2 things. What's the first thing I would do with this negative 5? If I want to get this by itself, I got to move this and that way, right? Got to move it over there. So what would I do with this 5? Yeah, plus 5. So now it becomes x plus 5 equals negative 2/3 y. And what would I do with this? I divide it, right? Because now it's multiplying here. So in 2 steps, we've done it. And as funky as that looks, that could be your answer. You don't have to write equals y. You just have to write that. You're doing the inverse of both things you see in the equation. We're adding 5, and then we're dividing by it. And we're doing it in a different order than what's presented. All right, if I do the second one for you, let's start by distributing. I find that to be easier. You don't have to. There's another way to do it. But I think it's simpler. So if I distribute the equation looks like that. Whoops. Oh my gosh. Get out of there. And then I'd solve. I'd do two steps. What are the 2 steps?
You lost me. Sorry.
One of the 2 steps I would do to solve for y. I would add 10 and then divide by 5, right? You can probably do these in your head if you get the idea down. All right, so if I add 10 over here, it'll be x plus 10 divided by 5. All right, so a lot of them will look very similar to what they started off as. They'll just be written differently and in a different order. Right? They'll use the inverse operations. All right, so that would be our answer there. Kind of funky, but all of these look like this. You just have to solve them back the other way. Don't forget to switch the x and the y to begin with. Understanding that g of x over here really means y. All right, give it a shot. You guys have your